Hey everybody. Today I'm just going to do a casual live stream. I'm going to work on the 3D models for the camera slider a little bit. And I'm going to go over the electronic setup for the camera slider and talk about future changes. And I guess just hang out and do a little bit of whatever. So right here in front of me I have the current assembly, well, not the one that's on the GitHub, but the one that I'm working on getting released for, or ready for release. It's going to be, well, the x-axis and the y-axis are pretty much going to be the same, but there's going to be some new mounting plates and the new adjustable z-axis. But before I get into the 3D models, I think I'm going to go over the electronics. Let's see, let me switch my camera. There we go. So for the electronics right now, on the main camera slider, I'm using an SKR 1.3. I'll just get that ready. I'm a little bit unprepared today, but that's not a surprise, right? I'm always unprepared. And let me close the window. There we go, that lighting's a little bit better. Okay, sorry about that. Yeah, the electronics. So right now, everything's running on an SKR 1.3. That's this board. And then I have TMC 2130 drivers. The reason that I chose this setup right now is just because of how easy it is to kind of do the initial setup. You basically just need to plug the drivers in, plug the board in, give it power, and you're good to go. There's a lot of alternative boards that you can use the TMC 2130s with, but you generally need a wire loom like this. Let me see if I can get, there we go. And these are kind of a mess to work with. So the SKR 1.3, it has it all built in, so you just need to change a couple little jumpers on the board to get the sensorless homing functionality instead of messing with the wire loom. It's so bright in here. One sec. There we go. That's a lot better. So where's my breadboard? There it is. And where's my other breadboard? Anyways. So there's a bunch of different electronics that you can use to control the camera slider if you want, that are a lot cheaper than the SKR setup that I have for mine. The original camera slider ran on an Arduino Uno and one of these little CNC shields, so you can get these for under $10. And if you use A4988 stepper drivers with it, you can cut the cost of the electronics by, well, from about $10 compared to $50 or $60 if you're using an SKR. So that's one option, but if you're going to use this, you'll have to run either a slimmed down version of Marlin or Gerbil 1.1. I think this is designed specifically for Gerbil. I need to get the camera up a little bit. There you go. So that's one option. This costs about $10. Another option for control is just a spare 3D printer control board. I have a couple of these just laying around. I don't have a Ramps 1.4, but this is an old PrintBot control board. Basically any 3D printer control board will work. And some other options are, here's an ESP 01. Oh, actually no, that's not an ESP. This is the ESP. That's an NRF module. Forget about that. So, dropping everything. The ESP01, you can get these for about $1 or $2 online, and these are Wi-Fi enabled microcontroller, and they're very useful. You'd have to do a little bit of tinkering to get it to control 3 stepper motor drivers, but it's definitely doable. Here's a ESP8266 breakout board. It has kind of a breadboard compatible pinout on it, and built-in there's a built-in serial communicator, so you can just plug it in and program that over the USB. It's a lot more convenient than the ESP01. Another option, this is another ESP8266 breakout board. Oh, dropping everything today. These two are basically identical, just a little bit different size, and they use a different serial communication, so basically the same thing. Another thing you can use to control it is, here's an Arduino Nano. You can get these for $1 or $2 online. You would run Gerbil 1.1 on this instead of Marlin, but you could easily set this up with a couple of 84988 stepper motor drivers, and then you could have 2-axis control running on Gerbil 1.1 for like less than $5 for this setup here. So this one is basically you get the exact same functionality from this Arduino Uno with the CNC shield as you would the Nano with like manually wiring everything up, but this would be like $4 and this is around $10. And here's a different Arduino Nano, so they come in a whole bunch of different colors, sizes, flavors, whatever. And then one last microcontroller you could use. This is an ATtiny 85. You can get these for about $1 online. They're pretty tiny. You can just program them over USB using the Arduino IDE, and kind of similar functionality, but you get less pins and less of the nice stuff as like an Arduino Nano or something like that. So for the stepper motor drivers, like I was saying, I use the TMC 2130s in my main branch, but you can use A4988s, which are like 1/10 of the price. They come in a couple different colors. I have a red one here and a green one. For this kind of purpose, they're all basically going to be identical. You'll just put a heatsink on it, plug it in, and you'll be good to go. Not much to say about that. These cost literally like 50 cents each. Another option, this is a DRV, what is it? DRV 8825, is that correct? I can't read the chip. Anyways, the DRV drivers, these have 32 microstepping compared to the 1/16th microstepping on the A4988. But these also have 3 amps maximum output current versus I think 1.5 or 2 amps of these guys. They're a little bit more expensive. Some people don't like to work with them because they can be temperamental when you're using the microstepping. I've read online that they can sometimes lose their steps and stuff, but I haven't used these too much. I have a couple just laying around, but they are another option. And then after these, I would recommend the TMC line of drivers. So, one second. So here is a TMC 2130 driver. I got this from Big Tree Tech. These are about $8. Oh, they're around $8 a piece. These have stealth chop and sensorless homing, which I prefer over these guys because you don't need physical end stops. You can do it all through software. You can adjust current through software and all that kind of stuff, which is very nice. If you're willing to pay the price, then it's pretty nice. But those are the basic, that's like a basic overview of a couple different control boards you can use, different stepper motor drivers that you can use. It's like just a general glance at different things. In the future, I'm going to go more in depth, so I'm gonna rebuild a slider using this shield and Gerbil 1.1, and then I'll have 2 different versions. I'll have the main branch running Marlin, and then I'll have just a second one with Gerbil if you wanted to go with a lower cost option. I also have ESP32 modules coming in the mail, which are really similar to this guy. It has built-in Wi-Fi, but it also has built-in Bluetooth, so that should help with functionality and that kind of stuff. Although I'd have to run Gerbil instead of Marlin, I believe. Yeah. I was going to do this in the next stream, but I figured I'd just talk about it briefly. Just put those away. Put it back in my bin of microcontrollers. I also got another webcam, so I have a printer camera. Always wanted to set one of those up. This is an FL Sun. I think it's called the F5, but I've modified quite a lot of it. I have a different hot end assembly on there and a dual extrusion hot end, but yeah, I think it's kind of a cool angle. All right, I got that out of the way. Let's talk about the 3D models. So I gotta put this in here. Okay. So there's some stuff over on the left-hand side of the screen that's not showing up on the stream for some reason. But yeah, just bear with me for that. Okay. So this is the basic idea of the next step in the camera slider design. Here's the old X and Y axis that are up on the GitHub. The new Z axis is going to start with this mounting plate. Then there'll be two side attachments, and this piece here, I'm going to make that redundant. So yeah, these little blue pieces are going to clip onto the main Z-axis mount piece. Then up here on this shaft, an M5 bolt is going to go through that hole. That'll act as reinforcement for the shaft. Two 608 RS bearings are going to go onto that shaft, and then they will act as the pivot point for this piece, which is going to be driven from below by this stepper motor. So this stepper motor will be the third axis control. And then up here, I have these pieces. So this piece on the left side is going to get attached to that face using 4 M3 screws. So if I look on the back here, there's some hex traps. So M3 nuts will go in there, and then your M3 screws will tighten this face to that face. But then on the other side, there's a similar piece, although except instead of this piece getting attached with M3 screws, it's just going to sit on a shaft. I still need to hollow this out, but it's just going to kind of be pressure fit onto a shaft there. So right now what I need to do is just adjust some of the measurements, because I want everything to use a 250 to 268 millimeter continuous GT2 6 millimeter wide belt loop. So I need to adjust the distance of the motor shaft to this toothed wheel here so that you can use the continuous belt loop, and then I'll need to add a tensioning mechanism to that piece, and I will also need to adjust this right side. So I think that's my game plan. I'm going to start by measuring the distance for the belt. So I don't need tension. Don't need that guy right now. Don't need that guy. Okay, so there's going to be a shaft here on this. And the shaft is 5 millimeters. And I need to find out the measurement of the toothed pulley. So let me get my calipers. I can't find my calipers again. I find them and then I lose them, and then I find them again, and then I lose them again. Not in there. I might have taken my calipers out to the garage. Okay. Oh, my chair is so squeaky. My chair squeaks and every time I move a little bit. Oh, another thing I forgot to talk about. This is a MKS Mini. This would also work as a control board. I just found it, but I figured I'd mention it also works. Okay, back to this. So I've already made a model of the tooth pulley right here, so I could, instead of using my calipers to measure one, I can just copy this model. Yeah. Where did it go? Oh, sorry. There's a menu on the left-hand side here of the different models. It's not showing up on stream, so if you're wondering why I'm going over here and then stuff's appearing and disappearing, it's because you can't see the browse. Actually, one second. There, okay. So now you can see it. So these are the different components of the assembly. And then, yeah. I was wondering why it wasn't showing up. It was because I was doing a window capture, not the desktop capture. Although I do prefer to do a window capture instead. Anyways, so I need to align. First off, I actually need to get rid of that extrusion, because I need to align this. Modify, align, modify from there to there, flip. Okay, now I just need to move it on the X and the Y. There we go. Close enough for me. Okie dokie. So now, yep, those teeth line up with this wheel. That's what I want. But I want the distance from, I have to calculate the belt length around this and around the tooth wheel. So, yeah, I want capture position. So the way I normally do it, I figure out the radius of the circles. This one's actually 12. So actually, yeah, the diameter, not the radius, sorry. And then I kind of eyeball it from where it will come down. Trying to just roughly get an idea. So 70, 70, and then I need to calculate. Yeah. So it's 140, and then the diameter of this is, what was this one again? 65. Okay, so circumference, half of that would be 104. So it's 244, right? 7 times 2 plus 1. Oh no, it's not 104, it's 1. Two. And that was 12. So that would be plus 37.7. So I don't know, I can't do that in my head. 18.85 plus 252 is 260. So that's too big. The belt right now is definitely too big. So I need to move the motor up a little bit closer. Yeah, that's what I'll do. So right now what I just figured out is the continuous belt length that I need to go around this piece right here to act as the z-axis, or to join the z-axis motor to the this main wheel here, would need to be 260 millimeters, and I want to bring that down a little bit. Wait, yeah, that's what I said, 260. And I wanted between 250 264. Yeah. So, one sec, I need to look at this on paper. Let's see. So 250 to be as smallest. So it needs to be, I need to bring that up at least 7 millimeters. Yeah. Okay. Just step back a couple times. Literally, all I'm going to do is try and use the move tool. Bring this guy over here. See, I'm going to translate. So I'm going to do, instead of doing a free move, I'm going to do a translate. That way all the movements I do are with respect to all. Oh, what did I just hit? I hit my keyboard. Sorry. So I'm going to do a translate movement, as I was saying. That way every movement I do is with respect to the origins or the planes instead of the model. Operation cannot create. Oh, I see why I just bought it too. Because there's a fillet there and a chamfer, and it's trying to move up onto a flat plane, so it's probably like I can't figure it out. Or maybe it's this piece right here. Yeah, okay, it's the main circle. Never mind. Sometimes when you try to do just the move command on holes and stuff, it doesn't like it. Better to work on these two. Yep. So I needed to come up 6. See if it'll work on these guys. Bring this up. No. So when it's going from the fillet or the chamfer and the fillet, and it's trying to transition to this flat plane, it's giving me some errors. So I'll probably just have to redo those holes and this main hole here. But that's okay. It's a pretty boring stream. I want to look and see how my printer's doing. Where's my printer? Printer's still printing. Okay. I think I need to adjust my noise gate because it looks like the printer noise is getting through. Well, actually, one second. I'm gonna listen to my own stream for a second. No, it sounds okay. Microphone quality could be a little bit better, but I can't really afford a better microphone right now. I spent all my money on cheap Chinese electronics. Okay, here's an idea that I had the other night, and I'm just going to say it because I was thinking about it again. What if I've got these 18650 batteries. These things, I was thinking, what if you take one of those and then like one of those taser modules and a crossbow, to make a taser crossbow. That'd be pretty cool. And I have a motor with a worm gearbox in it, so I could motorize the crossbow, so then it would be an automatic reloading taser crossbow. Sounds like something Michael Reeves would do, but I've always wanted to build a crossbow. Alright. So the holes are 31 millimeters apart. I just happen to know that from doing it a lot. So that. I'm going to make these holes 3.2 millimeters so that you can put an M3 bolt in without much fuss. Because if you make it exactly 3 millimeters, then the holes are going to come out messed up. Too small. Not messed up, just too small. My processor does not like it when I work on this model. Constant freezing. I'm going to be due for an upgrade pretty soon. I want to get a Ryzen 7 3700X or something like that. Maybe the 3800. I don't know. Who knows? I don't even know what I want. Gonna make some holes here. Like, why are you making holes? It's for the head of the bolts in case you want to use the hex head that have like a 4 millimeter head on them. That's symmetric. Did I go too far? Is that only... Oh, is the motor too close? That's why. I need to adjust that motor. Okay, I'll finish the sketch and then adjust the motor body and gear. Oh, I see. I made a mistake. Need to move this guy up a little bit too. I need to move that up 6 millimeters. Why is it square on the bottom but rounded on the top? 6. There we go. Up 6. Take this guy, move this guy, up 6. Cool, cool, cool. Now, yeah, I'll capture position. Oh, come on. Can I go back 4, or will it? No, it goes all the way through. So, what could I do here? I can make this a little bit thicker, but then, yeah, that's what I'll do. Wait. I don't even need the recessed holes for the hex heads because there's nothing here that will get in the way of them. So you could, yeah, I don't even need to do what I'm doing right now. I don't even need to be doing that. I can literally just forget about that. Okay. Alrighty. What am I I doing now? I gotta make another hole in the center for the shaft of the stepper motor. Cool, cool. Oh, life pro tip. In Fusion 360, if you're making a measurement, see how right here, where it's highlighted, it says 31 millimeters? You can do mathematical equations in here. So you could do 31 divided by 2, and it will just have it. Instead of having to figure out, oh, it's 16.5 or whatever, or 15.5, it's just type divided by 2 or multiplied by 2 or whatever you happen to need. And you can find the center of a square really quickly by just going corner to corner and then just divide by 2, divide by 2. But anyways, the hole at the center of a stepper, was it like 20 millimeters, something like that? They all have a little bit of a lip on them. Okay. So motor mounts into there, shaft comes through, that is raised up 6 millimeters, so it will work with a 250 millimeter belt. Just need to adjust the position of the motor body. I'm kind of excited about this new design because you'll be able to mount your camera. Well, not only will it accept much larger and heavier cameras, like you'll be able to put like a 5 kilogram rig on this thing, but you'll also be able to focus the placement of the camera center, have it centered with all of the axes of rotation. That way you don't get any funky like parallax effect and that kind of stuff, and it will work a lot better for composite photography. So I kind of am excited to see where I can get with this today. I really want to get some parts on the printer and printing, so I'll probably be working on this for at least another hour. It's only 6:30 right now, so if I feel motivated enough, I might be streaming for 5 or 6 hours. Who knows? Probably not. Let's see, just the motor body. Okay. Before I put a chamfer on there, I'm gonna increase the size of this by a little bit. It would probably be easier if I split this all up into individual components and then I was working on it separately, but it's really hard for me to stay focused on what I'm doing if I can't kind of visualize the entire assembly, if that makes any sense. I like having it all like right in front of me. It's definitely not the most efficient workflow though, because if you have a slow computer, then it's really slow. How far is the motor? Okay. That needs to go in, and then this would be flipped on the actual one. So in actuality, this little tooth pulley is backwards. This piece should be on this side. So I can fix that. Just not rotate it. Why did I shrink the browser? Because I need it. Join those two components. All right. Okay, this bearing mount is obsolete. Get rid of that. I need to find some good copyright-free music that I can listen to while I'm streaming. All I've got in the background is the noise of my printers. Oh, it froze again. I'm gonna go get a cup of tea. Cup of tea for me. Be right back. I'll be like 2 minutes, so. BRB. Alright, I'm back. Fed the rabbit, fed the cats, got a cup of tea. So what was I doing? I just finished adjusting the measurement between these two pieces. Yeah, okay, cool. So let me isolate what I'm working on a little bit. Make it all invisible. Over here, I was working on a piece for a 2020 aluminum extrusion, but then the whole reason that I went from 2020 extrusion to a 2040 extrusion is stability. And you can literally just take two 2020 extrusions and put them side by side to make a 2040. You don't have to buy a pre-made 2040 extrusion. So I don't know if it's worth the effort to actually redesign the whole bottom of the x-axis to support a 2020 when you can just use two 2020s. Like, you can just put them side by side. Now you've got a 2040. Get rid of it, it's 2020. Get two 2020s, put them by side. There you go, 2040. Anyways, that way I don't have to redesign everything. And it's significantly more stable. Because it's just wider. You have less of there's less of like a lever action on any offset forces. They don't, you know, you know what I'm talking about. Plus the feet are designed for a 2040, so yeah. I'm just lazy, that's the gist of it. I'm gonna adjust this piece. There we go. Actually, that's not centered at all. What am I talking about? Yeah, that's not centered. What am I doing? I should just delete this piece right here. Move this top piece down. Translate it down with respect to that piece so that they are same height. Oh, I see. It's not properly aligning them because they have chamfered corners or fillets on the corners. So if I delete these, and then, yeah, okay, this is what I wanted to do. So I deleted the curves on the corners, that way it's just aligning two flat planes together. So these are the same, yeah. Those two are the same height with respect to this piece. So then in order to match that shaft right there, I'm going to do this. Big brain move. I'm just, instead of making a new sketch on this face and then building the shaft from scratch, I'm going to take the profile, I'm going to extrude it over as a join movement, but I'm going to do it as a offset plane. And I'm going to offset by, so it's 186.7. I want the shaft to be, the shaft needs to be twice the depth of a 608 bearing, which is 7 millimeters. So it needs to be 14 millimeters minus just the tiniest bit so that you can put a M5 nut through there, or an M5 bolt and an M5 nut, and tighten it down on the bearings. Because if the shaft is too tall, you won't be able to tighten the nut down to lock the bearings in place. And if it's too short, well, I guess if it's too short, it doesn't really matter as long as it's not too short. But like, so I want the shaft to be like 13.8 millimeters, which would be 0.2 millimeters shorter than the depth of two 608 bearings. Yeah, that's what I'm thinking. So I want it to be 186.7 offset. No, that's not what I'm saying. That's not what I want to do. Sorry. Oh, the offset plane's on that side, is it? No. Oh, never mind. Okay, I'm having a brain fart. Forget what I'm saying. I want the extrusion distance to be negative 13.8, and then I want the offset plane to be 186.7. Okay, so I did have it right. I just had my extrusion distance incorrect. 13.8. There we go. So this is what I was trying to accomplish. Is through that extrusion. And that little maneuver probably cost me more time than it was worth. Oh, it did too, because it's still considering that piece part of this component. Okay, forget. I was trying to be smart and I was stupid. Forget what I just did. I'm gonna do it the old-fashioned way. So the inner diameter needs to be 4.8. That way when you put your M5 bolt into it, it will actually thread into the plastic a little bit. And then the outside needs to be 8 millimeters because that's the diameter of a 608 bearing. Actually, no, not 8. 7.9. So there's a 0.1 millimeter tolerance in there. Span at 13.8. What am I forgetting? There needs to be an offset at the base of this to raise the bearing up so that it doesn't rub. Okay, so yeah. That's 14, and then you need to make an offset right here with 14 diameter. Raise that 0.2. Okay. So this little piece here, that's going to raise the bearings up so that the outside shell of the bearing doesn't rub against this face and create unnecessary friction. A chamfer there, 0.2, and the bearing is rounded on the inside, so I'll do 0.8 millimeter on the shaft. So push your bearings down onto that. .4 millimeter fillet or chamfer, whatever you want to call it. Goes there, other one goes on the other side. That is the alternate version. So that I'm going to release later. This tensioner I'm actually going to get rid of because I think I can build it. This piece originally acted as an attachment that would go on this face here. So that would go like down there. And then this would be the shaft the bearing sits on, but it was only designed to hold one bearing instead of two, which is not as stable, and the hole for the shaft didn't go all the way through. And it just added more pieces to print. So I'm going to try and take this tensioning mechanism here, this area right here. Oh, 1 second. My rabbits just escaped their cage and they're trying to get into the bag of pellets. I can hear them. Sorry. Lucy is an acrobat. She does like a flying jump out of the cage on top of the main cage that they have. So they have like an entire bedroom to themselves, but we have cages around the walls so that they won't chew on the molding and that kind of stuff. She does like this crazy flying jump out into the closet, and then she tries to get up onto the shelf to get the pellets or whatever. So she's a fiend. Anyways, that tensioning mechanism, I'm just going to keep it there for reference, but it's going to be obsolete. But in order to actually... okay. Let me finish up with this side before I focus back on that side again. Sorry if the stream is boring. I was kind of unprepared. I wanted to have a little bit of a schedule today, but like 10 minutes before I was doing the stream, I was at the post office trying to ship off a couple orders, and I looked at my watch and I was like, uh-oh. So, I'm pretty bad with time management. Capture position. So for this shaft, you're going to use an M5 by 30 millimeter bolt. Yep, that'll work. And just save everything. Okay. Got that bug again where the origin won't disappear. Round over the corners. I forget how I got that to disappear last time. I want to put hexagons on this because hexagons are cool. The more hexagons, the more cool. So I'm going to find a center line. Going to make a hexagon. Going to use my delete, hit T, and then that switches to delete. I'm going to make two lines. One of them is going to be from the center to there, and then the other one's going to be from the center horizontally out. Select the entire thing, create rectangular pattern. Next, I'm going to deselect those two lines. Over here, rectangular pattern. I'm going to go distance spacing. Now I'm going to increase the spacing a little bit. Instead of direction, I'm going to make it symmetric. And increase the numbers until I see enough hexagons that I'm happy. Oh, for directions, you want to click it and then click those two lines that you made earlier. Like that. There we go. That's a true honeycomb. Make that symmetric as well. Just make a whole bunch. And I'm just going to pick a pattern I like and then I'll extrude it. You might be thinking putting a whole bunch of hexagons through the piece will make it weaker, but it basically it forces the slicer to generate parameters there, and it will actually make the piece more rigid and use less material. Because parameters are better than infill. Cut it through there. That looks cool. And then if I print that with like dual extrusion, do black parameters with like glow in the dark blue, that'd be cool. But that should actually make that significantly more rigid because it's going to be printed, once this unfreezes I'll show you what I'm talking about. But it's going to be printed laying down flat on its back so that the layer lines are going to actually be, yeah, so it'll be printed like this. So it'll be printed up, and then those hexagons are basically going to force perimeters instead of infill. Should make it a little bit more rigid and also cool. So down here I have some nut traps and then holes for M3 bolts, although those don't actually line up. I think this piece is a little bit misaligned. Yeah, it was just a millimeter off. Yeah, okay. So you put some M3 bolts through here. I'm actually going to get rid of these because they're not necessary. There we go. M3 bolts. And there's nut traps. Those nut traps will tighten everything down to grab these. This little area here will act like a clamp and it will bite into this piece, and that will hold it nice and secure. That's the idea, at least. Capture position. How's my printer doing? It's printing. Need to focus a little bit. Let me see if I can do that. Resolution, custom. 1920 by 1080. There we go. 84 minute. Audio capture mode. Don't use audio. FPS 30. Configure video. There we go. Huh, seems like I can't even control the focus on this. I only got brightness and exposure control. Interesting. Well, this web camera is cheap. So. Video decode. Sorry, I was just looking at the camera settings. Anyways. Yes, this is what I was doing. I was looking at the measurements for the hex traps. Well, it's kind of like a face. Those are 3 millimeters, so those are way too big. I thought those hex traps looked way too big. I'm just going to make these invisible for a second. I need to redo these hex traps. When I first was working on this version of the camera slider assembly, I think it was about 14 months ago when I first made it, I was not very good at 3D modeling. I'm still not good, but I was way worse. That's why I'm basically redesigning everything as I go. So I want this to be, needs to be 5.6 millimeters, so I'm going to make it a little bit undersized. Yeah, look at the difference. That's how it actually, the size it actually needs to be versus the size that it was. One second, I'm going to put on a little bit of music for myself. Just helps me focus. I'm not going to play it on the stream just because even if I have the video enlisted, I can get like copyright claimed and stuff like that, and I don't want the stream audio to get muted or anything. But I need to find some good copyright-free music, you know? Sum 41, I haven't listened to them in a long time. We'll listen to some Sum 41. Just going to change that a little bit so that it's more structurally sound. Should probably copy that change for the opposite side. I have to repair that piece underneath. It looks like I messed it up. Swear to God, my rabbit just escaped again. There we go. I don't know why she escaped. I closed the closet, so there was nothing for her to get. Print still printing? My bunny Lazarus came to say hi. This is Laszlo. He's a nice little bunny. There's my cat, Kira. Kira. She's very loud. It's an animal party. I also have to adjust the position of this piece by 1 millimeter over. And there's 2 holes there for some reason. Must have messed up. I'm going to modify align these two. This actually from that to that. No. What am I doing? I should just delete this tensioning mechanism because I know what I need to do now. Kiro, shush, shush. Shh. Kiro is 19 years old and she's deaf, so she's very loud. So 2 bearings going here on that side. 5mm by 30mm bolt goes in the middle. 2 608 bearings on that shaft. 2 608 bearings and a 5mm bolt. Same size, same setup on this side. Then, M3 bolts go in here, and they join that to that. Oh, bunny on the keyboard. Sent Lazarus off to go home. Alrighty. I'm going to see if I can put the assembly together and then animate everything. Oh, I gotta round these corners. Can't forget to round the corners. What did I do on the other side? 20mm or 10? What was this side? 20. Nope, I want to get rid of these. Motor body. Here. Okay. This can go to the bottom. Oh. Can't let the rabbit eat the cat food. Let me see what I got set up here. That guy can go away too. That is the old x-axis mount. Hero, stop. That piece is upside down. Why? Why is that upside down? I mean, it's aligned, but... Oh, I copied that and then I flipped it for that. That's why it's upside down. Okay. So... need to do an as-built joint. There we go. It's fun to watch, just to play around with stuff once you animate it. I just like moving stuff around. Sorry. Next up, this guy. Assemble as built joint, components that and this. Instead of a rigid joint, I want to do a revolute joint, and I want to make the axis the center of that shaft. Ta-da! Next up, this guy. Assemble as built joint. Rigid body, join it with this guy. Alright, what am I making? What am I doing wrong? Nothing. Assemble motion link. And that guy and this guy. I think it's 60 to 360. I think that's it. So now I'll explain what I just did. Let me just turn Sum 41 down a little bit. Okay, so what I just did is, one second, I gotta close the door, my cat's yelling. Nothing but distractions with the animals today. Okay. What I just did is, so I have the whole model assembly. I've been modeling everything in the place that I actually want the pieces to be when I assemble the final thing. So doing it that way is pretty handy because when you go, you can assemble everything as built joints instead of modeling things separately and then putting them together after the fact. When you model them together, you can just do an as built joint. So I did that for all the pieces. I joined everything I want to be static together, like they're going to be fused or locked together, I did as a rigid body joint. So this piece, this piece, this piece, the motor are all rigid body joints with each other because they're going to be bolted together. Then I did a revolute joint on the shaft of this motor right here and a revolute joint on the shaft of this piece right here. So when these rotate, they'll basically rotate together. Let me animate that for you. Animate joint. So when that guy down there rotates in the model, it will rotate with this. Although I think I actually have them grounded, so I can't. Is it grounded? No. It's just giving me a problem. Oh, I know why. Anyways, you can use motion links to join two joints together so that one joint moves, the other joint moves, is the idea. I don't know why it's not letting me click and drag this guy right here. It's not grounded. That's not grounded. Maybe just because the entire assembly's on, it's all wibbly-wobbly. So I'll revert position to put everything back. Next up, what I need to do is put a whole bunch of hexagons on this side. Because it just looks, it looks good on that side. I like this side. All those hexagons, that looks cool. This side, there's no hexagons. Not cool. So that's what I'm going to do right now. Oh, they're not aligned. I just noticed that. That one, this guy needs to come over just a tiny little bit. So to do that, I'm going to, where's that rigid body joint? This one? to see which one is which. I think it's this one. Edit joint, is that it? Yeah, that's it, okay. So if you want to see what bodies or components are in the joint, just edit joint. So I just want to suppress temporary. I think suppress will work, and then I'll do the changes I need to do, and then I can. Actually, you know, I don't even want to waste my time fiddling with that, so I'm just going to delete that joint. And move the body over. That was 1 millimeter. Oh, are they still linked? Did I delete the wrong rigid joint? Give me a second to figure out what I'm doing now. Oh, I deleted the revolution. I'm a fool. That's what I wanted. I deleted the wrong joint by mistake. Okay, what am I doing? What am I doing wrong? Oh, I deleted the wrong joint by mistake for a second time. So the joint that I just deleted was this piece to the motor. And I want to delete this guy, which is that piece and that piece. Okay, my mistake. Double mistake. And now, finally, should be able to move this. That's the problem with joints, is if you don't do it right and then you put joints on everything, you gotta undo it to fix your own mistakes. But that's completely my fault. There we go, look at that. Okay, so now we're aligned. I'm going to capture that position. And assemble as built joint. So I could do Shift J instead of just going there all the time. How's my printer doing? Almost done. Fusion 360 is frozen again. Oh, this piece is a nice rounded edge and that piece is a angle. I'll fix that and make them the same. And this, that, and that. Probably should leave that a little bit thicker, because with the printing orientation, you want that to be strong. Oh, let's do 5. What's the distance from here to here? I think I'll have 140 millimeters, I think is what it was. those. Okay, this is on, yeah, that's on the front. Now the motor. Oops, geared bracket. I've got two of them. Why do I have two of those? Might have been an accident. Alright, I'll just move all this back down. There we go. Should just use the align tool for that. Not that. I selected the wrong thing. From that to that. I miss version 1 of the camera slider. It was so much simpler. It was just like a motor that was duct taped to a piece of aluminum. One's in chat if you love camera sliders. There's nobody in chat. Oh, I keep doing that. Doing it wrong. Doing it wrong. Adam, focus. I did it wrong again after I told myself to focus. Gotta select that first and then this. Yes. Oh, I see what I'm doing wrong. This piece right here is a little bit too close. It needs to go 0.2 millimeters that way. And then this guy needs to go 0.2 millimeters that way, right? Point one. Leaves a little bit of a gap for a tolerance in their FDM printer. And then on this side, oh, I see. There we go. That's fine. Close enough. Capture position. How's my printer doing? Almost done. It's getting there. What's going on with this guy right here? Very unusual. Why is that doing it? Not even let me fix it. Error? What in the world is that guy doing there? I can fix it. Nope, that's not even, I'm not doing it right. How could I fix that? I know how I can fix this. Kind of a hack way to get rid of it, but it's not letting me delete that face. Oh, printer just finished. Cool. Oh crap, looks like I was having an extrusion problem on one of the stamps. That's not good. I'm gonna have to reprint this one. Yeah, I can split it apart by hand. Huh. Looks like I had a little bit of a extrusion. 1 second. Just gonna have to send something off to the printer for work. Those things don't need to be nearly that long. Gotta just get something ready for printing. Oh, there we go. Sometimes my dual extruder has a little bit of some problems. It's not the greatest. Printer settings, filament 1.25. 212. I'm going to try switching up 215. Layer height. There we go. Move that guy over a little bit. There we go. Got a print ready. So unfortunately, the first time I tried to print that stamp, for some reason, when it did the first filament change from black to white, looks like I had a bit of an issue extruding for a couple layers. So gonna let that printer heat up while I work on the model. Give this a save. It's gonna freeze for a minute. I'm gonna go see if I can get my rabbit Alfred. My rabbits are sound asleep now. Okay, Spotify. Put on some music. Oh, printer's starting. I want to see what it does, or see how it looks through the webcam. Well, that was pretty close. The fans almost hit the camera. This poor machine works 24/7. I've been meaning to upgrade it to a Core XY for a long time, but parts are still in the mail. They've been shipping for 4 months. Who knows when they'll get here. I'm gonna go for the nozzle. extruder clogged? Is that why? Must be. Yeah. The extruder's clogged, that's why it wasn't printing. Have to fix that. Cancel print. A little bit of a detour, 1 second. Yeah, there we go. Just gotta cut that off. Here we go. Now it's extruding again. This is it's an XKR or an XRC 3D hot end thing. Let me show you. The hot end I'm using on my cube right now. Do I have pictures of it? I don't have any pictures of it, but it's a low-cost Chinese hot end and it clogs a lot. Let me just restart that print. Alright. If you're looking for a dual extrusion hot end, like a multiplexing one for your printer, I do not recommend the 2-in-1 S1 that you can find on AliExpress. It's like 35 bucks, and it comes as a... I'm switching my webcam, I'll show you. Let me look at that. I got it in here, 1 sec. This thing. So this guy, the 2-in-1 S1 dual extrusion hot end, comes in a little kit like this with this style of hot end assembly. Do not get it. Don't buy it. It uses this little Teflon adapter that goes into the hot end. You can find these in different hot end assemblies, but it's a pain in the butt. If you print PETG or ABS with it, this is what that little coupler is going to look like. Look at that. And it's sticky. It's like sticky to the touch because the PETG or whatever deposits around the outside. So if you do PETG and then you switch back to PLA, it's just going to clog every single time. Every time you try to do a filament change, it like stretches the filament and then it breaks because it's so sticky on the inside. So avoid that hot end. It'll give you many headaches. Alright, back to what I was doing. Which was putting on Run the Jewels. Okay. I don't know what I was thinking when I originally did this model. I must have been super sleepy. Need more adapter holes on that plate, but for now, gotta check the alignment. Oh, gotta add those as reverts. Assemble as built joint, which is Shift J. So I'm gonna learn that hotkey. I'm just gonna start doing that. Join that body and that body on that center of rotation. Yeah, sure. Okay, and then I need the toothed gear. Oh, I gotta prime the printer, 1 second. There we go, it's actually working this time. It's printing. Check back in 5 minutes and just see a big blob of plastic on the hot end. Okay, so what was I doing? Assembling everything. This guy needs to be... How do I do a slider joint? Position. What am I doing? Oh, okay. So as built joint, Shift J. Want to do slider joint between this body and that body. Yeah, there, just like that. Okay. So now, if I rotate this, cool. Cool. So I think I actually have a rigid joint on these because for some reason I can't rotate this. Oh, I can rotate that guy. Okay. What if I'll ground that? Yeah, so... Okay. As built joint. Revert. There we go. Okay, and then on the slider, edit joint limits. Minimum. Oh, minimum is going to be negative. Maximum, like what? 25, 20. Animate. Put your camera on it, and there you go. Okay. Let me look at the printer. It's working. I don't need to make a rectangle, I can just make a line. Line would probably be better. Now, circumscribed polygon at the other side. Axis left click. Yeah, that's close enough for me. What did I just do? I hit a button. Froze. Where's the goat? He's in a barn. Sleeping. Actually, it's a she, too. I can't go see her right now. Social distancing and all. So what do I need to look up for? Those holes and then that main shaft. I had the spacing wrong on that. Crap. It's not right. I did that pattern wrong. There we go. Spacing. Gotta make sure I got the spacing right first. 3 by 3, yeah, that's what I want. Yeah, 11 by 11, symmetrical. No, I don't want those ones on the bottom. Do some more on the side. No, this is fine. I think there's going to be a collision between here and this piece, so I'm going to just check that. ground this piece right here. How's my printer doing? Still printing. Yeah, there's going to be a collision there. That's easy to fix though. So you can just make a circular cutout. Another option, I can make this piece a little bit thinner and then lift that up because it's going to hit the tensioner too. Can't move up because I got these. Oh. It's always something. So I got to delete these. Yeah. Should be able to just delete these and that will translate it into a right angle. It's probably going to tell me delete. There's an error on delete. Oh, it actually worked. Perfect. Do the same for the other side then. Should just go back and delete this in the timeline, but I don't know when I did that. That was in a whole different sketch. So. piece isn't properly aligned. It needs to go over a little bit. Have to adjust the rigid joint. That one and that one, so... Oh, Fusion 360 froze again. Cool. I'm just gonna save. Okay. Just looking for the rigid joint on that guy. Nope. Forget how to see which joints are on a specific model. Just click it, will show it over here? 1 second. Can I get rid of this stupid tensioner? Break link. There we go. Tensioner bar. Remove that. I forgot I had them all set as derives. That was probably slowing things down as well. Move. Okay. These two pieces here, I want to get these up on the GitHub. Do that after I get off the stream, I think. Maybe I'll take a look at them in a minute. I think I'm going to take a 2 to 5 minute break. I'm just going to go get a snack, have a granola bar or something, and make another cup of tea. So I'm going to be gone for a couple minutes. And when I come back, I will keep working on this. Be right back. Alrighty, I am back. Actually, I'm gonna go grab a sweater really quick. Alrighty. So what I'm trying to do right now is align these side pieces. So this guy needs to go that way by 0.1 millimeter, I think. Got to adjust my audio settings. Filters. There. Just going to adjust the compressor a little bit so that it doesn't like blow out your ears. There we go. That should be a little bit better. Which one is the one that I'm looking for? Not that one. Might be this one. Edit joint. Yes, that is. I should name these. Probably would be a good idea if I started naming these joints. There we go. Just takes a minute. What was it? Number 26? That was what I was looking at? Was it number 2? I forgot. Yes, it was. It was 26. Did I even do the right one? I think I actually got the wrong side. I did. I did the wrong side. Oh, I need to step back for a second and think about what I'm actually trying to accomplish. I need to move. What side is this? This is the right side. It's on the left though. It's because of my perspective. There. Okay. Need to move this back. So right plate motor would be rigid 29. Nope, rigid 29 is at least I have an idea of what that is. So that one's that one. It's not rigid 4. This one. Okay, so rigid 32 is 32. I can't move this because this is connected to this, which is connected to this, which is connected to this, which is connected to that. I shouldn't have done the joints when I did. It was a bad idea. Just made everything significantly more difficult. Hey, now future me knows that. So now I should be able to move this. Yes. Okay. So that needs to go out 0.2 approximately. Yeah, there's still tolerance there. Okay. That guy needs to go in a little bit, actually. And that one's a rigid joint as well, but that one I know happens to be 28, 26. So I needs to move 0.1. Yep. Okay. So I was literally 1/10 of a millimeter off. It's not bad. I mean, it is bad, but it could be worse. Alrighty. And then this face is like a little bit offset. 1/50th of a millimeter off. I'm not even going to worry about that. 1/50th of a millimeter is like, I've seen ringing bigger than that. So, speaking of 3D printing, how's my printer going? That's printing. Okay. Oh, but now I know that it's 1/50th of a millimeter off. That's going to kill me. No, I know that. It's always going to be there. I should fix it. Is it worth the effort? I have to move this entire top assembly. And what am I looking for down here? Yeah, I'm looking for this. And the motor. But I don't want that piece there, which is the, what is that piece? Gear bracket? Okay. I can't move them all. Okay. Never mind then. Capture position. That is less, it's 1.5 thousandth of a millimeter off. That's better than 1/50th of a millimeter. I can accept a tolerance of thinner than a human hair. That's okay. That's okay with me. Now I need to move this piece over by same amount. Am I doing it the wrong way? Yeah, I am. There we go. See if that's lined up with the other face. Yep. Okay. Good. That was easier to fix than I thought. Alrighty. That guy is grounded, so unground that. I must have deleted that revolute. Oh, I'm using the wrong y-axis geared bracket to do all that aligning. There's two of them. I have two of them by mistake. One of them is linked and then the other one's not. Yeah, so this one's not linked. But that one is. So to get rid of that confusion, I'm just going to delete that. I think I had that second one because I was testing out a couple things to see their fit. Yeah, okay. Box rows, just like components, this. Okay. I need to see. That will collide and cause issues. So how can I fix this? Lift that up. Yeah. I've been streaming for 2 hours. Doesn't feel like it. Frozen again. My computer freezes so much now, it reminds me of when I had Windows 95. And like 32 megabytes of RAM. No, I think when I had 95, I had 8. Can't remember. Find some new music to listen to. Listen to some Aerosmith. I haven't listened to them in a while. Okay, so there's a collision issue right now, or there was a collision issue. Will that hit? That should be okay. Although if there's M3 bolts in here with the head sticking out, it might be a collision. Okay, I'm just trying to adjust the side pieces here so that when it's all assembled, you won't get any collisions between this the housing for the tensioner and this bracket. So I'm just slowly kind of adjusting things. Oh, I think my printer's doing a filament change. Zoom in. Switching from white to black. I can barely see though because the camera's blurry. It worked. Cool. Oh, I accidentally messed up my my Fusion 360 thing. Oops. Let's see, desktop capture. There we go. Where is it? I messed up my... There we go. I messed up OBS. There. Okay, sorry about that. Oh shit. I just realized, yeah, there we go. I was like, why is that not doing the thing I want it to do? Yeah, 0.8. Maybe even 0.7? I don't want it to be too tight. Okay. I'm just going to remake these holes. I wonder if I should do maybe 2, instead of 2 bolts, 3? No, 2 should be okay, I guess. But I guess 2 on each side, it'll be fine. Oh, I put champers on this side, but not on the other side. I'll have to fix that up. Froze again. There we go. I'm gonna actually save right now. Always a good idea to save. Can't do that. 0.4 sounds okay. Yeah, that's fine. Next up, I need to make the holes. Just do them one at a time, I suppose. It's right on the edge of that. I guess if I move that in like 1 more millimeter. You know what, instead of doing that, I'm actually gonna... Can I bring this up by 1? If I bring that out... Yeah, that'll be a little bit better. Put a washer there with your M3 bolt. Actually, I can make a recessed, like a little hole there, a recessed hole for the M3 bolt to go into. That's what I'll do. Oh, I think the printer just finished. Yep. Oh, when I moved those guys, I forgot to move the holes. That's fine. One second, my rabbits are making noise. I caught Alfred, my rabbit. Oh, that's wrong. There we go. This is Alfred. Alfred's a good boy. He just likes to escape sometimes. Oh. Alfred is a very good snuggler. He's a 3-year-old Holland lot. I'm gonna go put him back in his house. Kiro, stop. Kiro. This is Kiro. Kiro is 19 years old and she is deaf. She's very, very loud. She likes to scream. So I'm just gonna put her out in the hallway. Back to 3D Mark. And I'm gonna put some new music on. Kiro, oh my god. How did you get back in here? Go. Go away. Go lay down. Okay. So I need to check the clearance now on this stuff. I'm going to ground the bearing mount. There we go. So it'll clear that piece now. Lots of room. Good, good, good. Now I just got to make sure it'll work with the tensioner in place. That's another thing I got to make sure. Tensioner. So there's this little piece underneath. You can put a 608 RS bearing on there and then use that to tension, but it's adjustable. So assuming you're using hex head M3, what is the distance between that and that? 2.43 millimeters. So that means I need to make some, what are they called? Countersinks. Actually, before I make those holes, I need to check to see how large an M3 washer is. If I can find one. I'll just Google it. Seven millimeters outside diameter on an M3 ISO washer. Is that what it says? Yeah. M3 3.2 millimeter hole diameter, 7 millimeter outside. Cool. So instead of 6, I'll make that 7.2 because that'll 7 millimeters for the washer and then 2 millimeters for tolerance. And that's going to go 2 millimeters in. Cannot wait until I build a new PC. I just want the next, like the next line of everything to come out. And I also want the Canadian dollar to get a little bit better. There's the countersink. I'm actually going to make this piece a little bit bigger now. Yeah. There we go. So technically, I think now it should be printable and ready to go. Other than a couple little, a little bit of cleaning up. What am I missing? I must be missing something. Let's see. I need a way to add like a counterweight, because with the NEMA 17 motor here, everything's going to be like leaning on this side. What could I use as a counterweight? 3D printing a counterweight would not be efficient. That'd be expensive. What could I use? I'll have to check my NEMA 17, see how much they weigh. Actually, I can check that online. Have to think about this. I mean, I could use like a pancake motor here because it doesn't need to take very much weight. And it has a gear ratio on it. So P7 on 10. So this, and this are now at a state where I'm pretty happy with how they are, and they should integrate with the old models no problem. That'll clamp together as it gets screwed down. I'm just going to export these and see how they look in the slicer. So that is an issue, the motor mount. We'll need support for that, but I don't want to use support material at all. You know, I don't even need like that recess spot, because once it's screwed into place, it'll be fine. Like, really. There we go. Oh, I forgot to deal with that. I'll chamfer there. You know, it'll actually be better this way, I think. Without that recessed area. Easier to print, definitely. Oh, my cat's eating cat food. Sorry if you can hear it, because he's very loud. Ozzy likes to eat very loudly. I'm gonna move the cat. Probably use PETG for this piece as well. Let's see how much material. 90 grams of material. That's not that bad, actually. You can see here how the hexagon design is forcing it to use perimeters instead of infill. That'll help make it a little bit more rigid. Excuse me. Plus hexagons are the best. It's not just about making it work, it's about making it look good. I feel like the geared bracket here needs some hexagons. Oh, it's not aligned properly. Ever so slightly off. Meh, whatever. As long as it's centered with the piece. We want to do it. Oh, it's cool. looking for spacing 15. No, I want to do 14. Hexagons. Love hexagons. Oh, problem with a sketch like this is just it's slow. There we go. There we go. That should force parameters instead of infill, and that'll make it a little bit more rigid. Should also cut down on the material usage, because those walls are 2 millimeters, I think. So if you're using 4 parameters, yeah. Cool. And then you can also access stuff underneath it. Cool, cool, cool. Made quite a lot of progress so far. Cool, cool, cool. Alrighty. I am going to take a quick break for like 2 to 5 minutes, and then I'll be back. So I shall return in a couple of minutes. Alright, I'm back. I got a soda pop. Ginger ale. Okay. So I got this, and this printable. Up next, I need to work on the work on this piece. So, assembly is gonna be weird. How are you gonna assemble this? So if I get rid of this piece, there's 4 nut traps, but they're positioned kind of awkwardly because when that piece is, you'd like have to put the nuts in first, and then, oh yeah, I guess that would not be too big of a deal because you put the nuts in first and then put the bolts in from the other side. Is the adjustable slider? Where's the other mounting plate? Okay. Oh, I guess you can access it through here now, through the hexagons. So that's not a big deal. Is that supposed to be a set screw hole? I think I did make that a set screw hole. But I'm gonna have to put a nut trap in there. So I could move those out a little bit. I feel like having 3 holes instead of 4 would be better, but just less hardware required. It would kind of involve taking that piece apart. No. I don't think it's worth the effort to rearrange all of this to use 3 holes. I'd save on 2 bolts and 2 nuts and 2 washers. Less stuff is good. I don't even know what length of bolt that requires anyways. How deep is this piece? 23.4 millimeters deep, so that's not going to work as is anyways. I'm going to have to fix that. No, I wanted that. I want that load. Okay. The washer, it's going to be 7. Then I need also a little bit of tolerance, so it should be 7.2, I think. I'm making some countersinks for the bolt heads. So it was 23, 7. An M3 by 20 bolt is what will be used on this piece. 4 M3 by 20s. Put in a nut trap here for the set screw. This piece is going to be tricky to print without support. I'm going to have to look into that. What did I do wrong? Oh, I see. Forget that thing I was just doing. I have no idea. Okay, so I just need to step back and look at this again for a second. This adjustment mechanism is not the best design. It's kind of a strange design too. Just thinking. So this side here, probably don't, well, I don't even really need a set screw because when it's in place and then this piece is on, that's going to keep it on the bearings. They're going to have nowhere to go. So I don't even need the set screws on these pieces. And then, so for adjustment, it goes up and down. And there are 4 M3 bolts, one on each corner. And there's a nut trap. pushes against this to kind of lock your camera in place. Trying to think of the best way to print this piece. You print it on this face, but then you might have difficulties with this big at the top of this, which you can always just clean up by hand afterwards. You could print it on this face, this going up. I mean, that would work okay because all these holes are slanted. And then all of these ones are straight 90 degree from that. Actually, this one doesn't even need the holes because it doesn't attach to anything. I can get rid of those on that side. This piece here definitely needs some more mounting points. So I'm just going to make something centered with this top piece. Kind of clear out the rest so it's not as busy, it's easier to see. It's hard to focus when there's so much stuff, you know. Adjusting plate. No, not adjusting plate, it is adjustable slider. Okay, there we go, that's a little bit easier. So I want, what is the size of the camera mount bolt? I think it's tripod bolt sizes. I think it's 1/4 and 3/8. Photography thread size. Thread size for photography equipment. 1/4 inch, so 6.35 and 7.93. That's 20 TPI. Okay. Cool. Good to know. Keep that over here. So yeah, I made that 6.6. So I must have looked that up before I originally made this. Alrighty. Actually, this would be easier if I did a rectangular pattern. What's the 3/8 again? 8 millimeters. I think there are over a total of 1,000 sketches in this assembly right now. So I take so long when I make a new sketch. I don't have very good modeling practices. But that's stuff you learn with time. Eight or nine millimeters. There, it's a whole lot of adjustment points, so you can put a whole bunch of different bolts. Hi Bradley, it looks like your message got deleted. I don't know what it says. Can't see it. Where is the goat? Everybody's asking about the goat. She's asleep in a barn. And I'm not in the barn. So no goat. I know that's not centered, but it's because it's offset for motor mounting plate. It looks like it's not centered, but it is. How much space do I get? It's like 150 something millimeters. How wide is my camera? Oh yeah, lots of room. That'll fit a pretty wide camera. I think that'll actually fit my phone too. Let's see. Yep, that'll just barely fit my cell phone. So, What? What's that distance? 153.2. My Pixel 3 is, with the case on, 149. So, cool. That'll fit all of my cameras and my cell phone. Yep. I wonder what's on Twitch right now. Formathrax is streaming cataclysm. No, watch him for instead of listening to Spotify. Okay. Oh, one thing I forgot, a critical error. I need, all these holes that I just made are for a 1/4 inch adapter. And I want something that'll fit a, maybe I'll make an alternate version of this that fits 3/8. All my cameras work with 1/4, not 3/8, but I'll make an alternate version of this mounting plate for that. And I actually might go back to that sketch that I did. Rectangular pattern, and I'm going to do 9mm instead of 8. Like that. Yeah. There we go. A little bit more material between the holes. Okay. So this piece is going to have some issues because the layers are going to be aligned that way, but I imagine with four of them, that's a lot of material. Should be pretty strong. This side is unfortunately a lot heavier. That is something you're going to have to address. Can't flip the motor around because then it will hit this. Maybe I'm just thinking it's worse than it actually will be. I mean, how heavy is the NEMA 17? Maybe a pound? I gotta get my motors in check. But anyways, I think I'm ready to throw a couple of these things on the printer. I'm just gonna check it, go over everything one more time, kind of smooth over a few of the edges, and then get it ready for printing. Oh yeah, the other Z-axis assembly. I need to look into that. This guy. Ah, my computer keeps freezing. It doesn't like it when I stream. I could extend the shaft on that side. No, because then you'd need a longer M3 bolt. Should actually check to make sure that M5 bolt will work. 21. What do I recommend? M5 by 30? That's fine. How about over here? And then that one's 21. So it's going to come out a centimeter. So -2. Well, I guess if you use 2 washers, then it will take up the slack. If you use some washers on this side, that way you don't have to buy multiple lengths of the M5 bolt. I'm craving pizza. I am going to go put a pizza in the oven. because I want pizza, and it's pizza time. So I'm going to be right back in 2 minutes. I'm just going to go throw a pizza in the oven. Alrighty, I'm back. Yep, the slider's motorized. Here, I'll switch to my webcam. Here's the slider. Sorry, it's kind of a mess. I'm covered in cat hair. There. And let me just plug it in. 1 second. Kind of hard to see the LCD. TMC connection error. Oh, it's I'm missing one of the stepper drivers. 1 second. I'm gonna put this guy back on. And now we're gonna plug it back in with the power cord. I got quite a bit of glare on it, but so right now it's motorized and it has 2 axes of motion. There's the y-axis and the x-axis, and I'm just working on the z-axis right now. In the stream I did, I think it was last week or the week before that, I got quite a lot improved on the software side. Now there's a custom commands section with, you can't even see it on camera, I'm sorry. Oh. Screen's just too bright on the LCD. Anyways, you can save positions and recall positions and all that kind of stuff, and you can print it off, you can run commands off SD, or you can run them over Wi-Fi. So, It's what I've been using to film all of my time lapses on my Instagram. So if you want to see a video that I did, let me switch back over to my desktop. So this is a time lapse that I filmed using the camera slider. So this is basically what the octolapses look like with the current build of the slider, with just X and Y motion. So just a kind of a basic time lapse, nothing really complicated going on here. It's just moving, slowly progressing on the X-axis and turning on the Y-axis. But let's see. Pictures. Yeah, here's some pictures that show it a little bit better. So that's the belt mount. That's the M5 bolt right there that goes through with a washer to support the Y-axis shaft. That's it with just the Y-axis assembly. Let's see. That's just a quick little GIF, a very little GIF I made. There. That shows it just doing a continuous motion on the Y-axis. Yep. It's nothing special, just a camera slider. Alright. So, what was I thinking about? I was just finishing up. I think I was just finishing stuff up for printing these two pieces. I'm going to try printing this piece today. So this is the biggest piece of the slider assembly, and it fits on a Prusa, no problem. Do I want it to be chamfered there? No, I don't. I want a hard 90-degree angle on that face. Okay. Should probably try and pull these teeth out a little bit, just a tiny little bit. There. Did I set a timer for my pizza? I did. All right. I selected the wrong piece. I'm going to get this piece ready for printing. Might want to move this nut trap in a little bit. So what's the distance on this? I think I designed it for an M3 by 10. Yeah, it's M3 by 10. So that. Yeah. No, I must have done M3 by 20. An awkward angle. I got all this other stuff in the way. Well, if I do an M3 by 20 in there, that'll work fine. But it's a little bit thin on the inside here. Right there. Oh, I don't have that selected, that's fine. Can't move it in 2, but I can move it in 1. Oh, there's a chamfer on the inside, that's why it wasn't letting me move it. Sounds like there's motorcycles outside my house racing. I live on a long stretch of road, so you hear motorcycles a lot. Well, I've been streaming for almost 4 hours straight. Probably gonna get off in a little bit. Probably stop around the 4-hour mark. I'm at 3 hours and 50 minutes right now, I think. Just want to check the thickness of the nut trap wall. I think I need to restart Fusion 362. It's gotten pretty slow. Yeah, it's kind of bogged down after a while, it seems like. I don't know if that's just me or... Alright, so 2.5 millimeters, that's fine. That's fine. It's time to print the new Z-axis mounts and test them out. Okay, gotta export that guy, flip it over, and I gotta delete this one. Yeah, that should work. The nut traps. And it will take 76 grams of filament with 4 parameters and, oh, I should do 0.2. Oh, I'm using my PLA. Six hours, that's not too bad. I could increase the print speed a little bit, but slow things down for PET a little bit. What if I did it PLA? What was it again? This piece I imagine would be fine in PLA. It'd actually probably be better because it would be have increased rigidity. But yeah, 80 grams of filament, 6 hours per time. So let's see these guys. So you can just barely fit the 3 Z-axis parts on one print. It's kind of close, but trying to design it also everything fits within the print bed of the Prusa as well. Like not necessarily on one print, but just this geared piece here at the bottom is the largest piece of the slider so far. So 13.5 hours and 176 grams of filament to print these 3 pieces. So that's not too bad at all. Can do that and have it done for tomorrow, and then I'll be able to test everything for tomorrow. Give me time to work on it a little bit more before the Thursday stream. Okay, so that's what I'm going to do. Actually, I'm going to switch over to the cube. And Jack PT. Oh, and for infill, gotta do gyroid. Gotta do the gyroid infill. I think my pizza's done. Yep, my pizza's done. 1 second, be right back. Alright. So I'm going to get these parts ready to print. I'm going to print them tonight. And then I'll assemble everything tomorrow, give it a quick test fit. And yeah, go from there. I'm going to cut the stream off now. I've been going for over 4 hours. So gonna relax for the rest of the night. I'm gonna be on Discord, so hop on Discord if you want to talk to me, and this stream will be available on the Patreon and on Discord in, well, probably a couple days because it's pretty long. They take a while to process. But thank you for watching. I hope it wasn't super boring. Next stream is on Thursday around the same time. Have a good day and a good night. See ya.